Hi friend, we got the Rat PCB in today. We're going to solder this up. If that sounds good, join me. Let's get this going. This is the PCB we got in, and I already see a mistake. See this right here where the knob's going to be? It interferes with where this switch is going. But we make mistakes. We all do. It's part of life. It's part of learning. All we'll do is, instead of soldering the switch directly to this PCB, we're just going to move it off into the enclosure and run some wires to this. Everything will be fine. Looks like this knob is also going to impede with the other two. I should have thought of that. Again, no big deal. We'll just run that lower in the enclosure and run wires to the terminals. No big deal. Let's get started. I'm going to do a little bit better on the soldering step by step this time, at least to get started. Okay, let's get these diodes soldered in here first. See, we're going to do reverse polarity protection diode first. It's going to be that one there. Goes in D1. See that stripe on that side? It matches up with the stripe on the printed circuit. Can't put this one in backwards. The clipping diodes don't really matter which way you put them in as long as you're consistent. But these ones definitely matter. If you put this in backwards and plugged in your power supply, it would just immediately short out. All right. And don't worry if you make mistakes. You could always undo. Let's not forget to clean our surface first. All about cleanliness and heat. You'll notice that when you get these clean as possible, that solder just flows right to where you need it. See that? I'll try to zoom in on that. All right, let's get this in there. These diode leads are always thicker, so I like to keep them for when I do the foot switch. All right, now you'll see how these have the stripe on this end, and these are glass, and if you bend them wrong you could crack that right in half, so be very careful. Let's mark these off as we go. We're going to do D2, D3, and D7. Very gentle when you bend those over. D7 is here. D2 and 3 are here. Whoops. Pull that through a little bit cleaner. I like to hold them all and just solder them all at once. What you're going to do is when you touch this off, you heat that pad up and the wire, and you touch the soldering tip. just to get that solder to start flowing, and then you feed more in. There we go. These leads are thinner, so I like to just clip them off and throw them out. You always want to wear safety glasses or face this away from me, because those will fly out. Those little buggers will hit you right in the eye. You know what? You can clean up the flux from the solder after you're done. And if you clip it off a little strangely, you can remelt it and make it look nice. Yeah, see that? Yeah, nice solder job on that. Okay. I'm going to get started on some of the other items. I'm going to do the resistors next, and I'll just fast forward this a little bit. Here's a pro tip: always put your components back where they belong. I spent 10 minutes looking for these. So how many do we need? Let's see. 1, 2, 3. R4, R5, and R11. Okay, if you'll take a look right there, I made a solder bridge just to show you what they look like. There's 2 pads that were already soldered, and I added a little bit too much solder and it bridged between the 2. Now those 2 places aren't supposed to be electrically connected. So what you could do is clean off your tip, heat it up, drag it out. See how it took care of that? Right there. If that doesn't work, if there's just too much solder, you can get your solder braid on there and suck all that solder off of the joint. But most likely, since we have good quality printed circuit boards, this will work because there's no connection between the 2. It's not, and there's no exposed copper. Okay, that takes care of the resistors and diodes, except for the LEDs, of course, which we're going to add later. So next we're going to do capacitors. Okay, we're going to put the socket in for our IC. See how it has the notch on the one side? Matches up with the notch on the printed circuit. We're going to put that in like that. What we're going to do is bend those little tabs in to hold it in place before we solder it. I always go towards the inside. There we go. Now it's in there mechanically connected, but we're going to solder it now. If we were soldering an actual integrated circuit, I always alternate where I solder. I'll start on one side and let that cool by going to the farthest one from there. And I'll go back to here. But since we're doing a socket, the integrated circuit's not there. But it's still good practice. The only thing I've ever fried so far was a switch, actually. They're a little sensitive. All right, let's get these LEDs in here. This one's off by itself, so we could stick that in there. Sometimes I like to balance it on something so it holds it in place. Like that. Now these ones are a little close together, so I'm going to put this one in first, and then we're going to put the other one in. If you get it in there started and you notice that you have it a little bit off the board like that, you could just do one at a time. I only did the one lead. And we're going to melt that back up while we push from the other side, like this. And it snaps in place. And then you could solder both of them in. There. Now this one we're going to place a little bit over, and we're going to bend it so that we have room here. Probably should have bent the other one instead, because we have to still solder where this potentiometer goes. We're going to do the potentiometer first. We're missing C4. 1 nanofarad. What how did we miss that? We learn to spot things like that by making mistakes. So let's make mistakes today. All right, now we can put this potentiometer in there. Now, the pots go on the opposite side, on the back of the PCB. And I got these ones with the plastic bottom. It's just an insert. You could buy them for the ones that don't have it, but I always buy it with that included, because when you put it on here, you touch it right up against the board with no problems. That's going to be a little problem too, isn't it? All right, we're taking this LED back out because it's the one that's going to have to be bent. Here's how you use this desoldering braid. Get to a clean spot and put it right over top of that and press it on. Now you're not going to want to hold it because it gets hot too. You'll start to see that solder wick right up on. See how it's sucking it right up into the braid? Sometimes you have to do a second shot at it, but this is good stuff, and it works fast and it works well. All right, now this should maybe pull out. Looks like we got to do a little more. If you don't start to get heat transfer across this, you could add a little dab of solder to the end, and that'll get it started. I know it seems counterintuitive to add solder to remove solder, but just like putting it together, it's all about heat transfer. She's loose. There we go. See? We can use it again by putting it on the top. That's problem is we don't know which leads which now. So let's get some more. We're going to put this one in on the bottom now since it's already bent. Get this solder out of this hole here. Sometimes you could heat this up and smack it on the table and it'll pull it out of there. And you can hold it up to the light and see if it's removed or not. The long lead goes on the square. Now this one's going to be bent over. Then we won't have any problem soldering that other one on there. Should have done it first. After I said that, we'll have a problem. But here we are. Okay, now I need to go grab another LED. You know, this one could go right in there. See that? Fits perfect. Watch out. Okay, I think the last thing we have to put in for this one is the bias potentiometer, the little trimmer that we added. All I have to figure out is where I keep my trimmer pots with the rest of the potentiometers. Let's see, are they in here? In an earlier video, I said that we were going to use a LM302. I meant to say an LM301. I put a correction in there, but just in case you didn't see it, let's go with the LM301 if we can't find the LM308. There. Here's our transistor we're going to stick in there. It's kind of in the middle of everything, huh? These ones need to spread out just a smidgen to fit in the hole. Now you see there's a flat spot on this side. The way we have it set up with the pinout correct, it goes with the flat spot on the front of the silk screen. And you don't have to press this all the way in. I just like to get it in there until it's decently tight. Okay. Whoa. Try not to burn your cord. I know some people like to cut and bend their components. They'll put them through, bend them so they're touching, and then cut and then solder. I guess because you could protect the ends from corrosion. But I think your electrolytics are going to die before any of that happens. It's a precaution some like to take. I have nothing against that. All right, what else do we have to put in here? We just have switches and potentiometers left and wiring. All right, let's get to that. Now we could put the volume and the distortion potentiometers in place, but that leaves this one. See the mistake I made? Mistakes happen. Here we are, no big deal. We could put them in this way, but it would take more room in the enclosure because this isn't over top of the board. We could do that, and then the switches would all be, and we could lay this out down here somewhere and run wires to it. But what we're going to do is we're going to put one of them in right now, maybe two, and solder them in. We're going to get the switches in, and then we're going to move this tone control elsewhere. We could put it here and run wires to it, and that way it will keep the layout correct, but then we completely have to move this switch out of the way. That's our diode switch. That's the one that does a lot for the tone changes. Here's something that I like to do on these. They have this little tab on the potentiometer. I like to grab a needle nose pliers or snips and break that off. That way when you put it in the enclosure, that doesn't impede it. What that's for is you drill a hole beside the potentiometer hole right next to it on the enclosure, and that keeps it from turning. But since we're soldering these to the PCB, it's not going to turn anyways. So let's put these two in, and then we'll decide what we're going to do with the rest of the switches. This one's fine, and this one is run by wire anyways, off board. Let me solder these ones in. Once you get them soldered in, you can push them into place so it matches where you have the circles from the printed circuit board silk screen. Bend them a little bit, and then when you drill the enclosure, it will pull them into place. And I'm going to break off the little tabs on these ones too. Yeah, I tried to pack this in a little too close. Nothing we can't fix. Just a minor inconvenience. Now you'll find that these switches, since the holes are large where they go into, they take a little more solder to get in there securely. Just let it flow in there. But don't cook these switches. As long as you're on and off, you're not going to cook them. But don't take too many chances. And after you do this one, make sure you move down to this one far away from it. You don't want all the heat going into one place on the switch. Now if you ever have to desolder a switch, sometimes it's just better to just throw the PCB out. They are hard to get out. Especially when you put that much solder in there. The way I made this, I made it so tight that there's really not enough room for everything to go in. It's a lesson learned, and you can bend these leads any way you need to make them fit right. And we're going to move this from being connected here. We're going to bring wires out as long as we can reach them, huh? We could always bend these up out of the way to solder something underneath. But that's what we're going to do. We're going to run wires from here to the potentiometer, which will be out here. We're going to relocate this switch in the middle. Everything else should be okay. Let's get those small switches in there. Here is our board. I added this switch. That's the one that takes the 47 ohm resistor out of the circuit. This one is, let me see. This one changes the slew rate, changes between these two capacitors. This one takes the 56K, nope, 560 ohm resistor out of the circuit. And this one is our asymmetrical switch. This is the most important one, I believe. That's the diodes. We're going to put this switch in there, but we're going to relocate it. So I'm going to run wires for this tone knob and for this switch. Here's another advantage of moving this potentiometer off the board. If you know how rat pedals work, turning up the knob actually takes highs out. It's called a high cut instead of a tone knob on the most rats, I believe. So if we put this in, and if you don't like that, all you have to do is leave the middle one in its position and swap the two outside ones when you put it together. And that way it'll make it so that it goes the other way. Not a big deal. And this switch, instead of putting it here, we could put it internal. But I really hate doing that, because what's the point of having an internal switch if you're actually going to use it? So we're going to run wires for this as well. Okay, here we are. I have the potentiometer moved off that we're going to put there most likely. And this switch can go anywhere we want in the enclosure. We could even put it on the side or at the top. Plenty of room. What we're going to do next is to test out all of these modifications. Let me restate this. I am very much regretting putting this many mods on this. But it's fun. So let's do it. Okay, this one went a little bit longer than expected, so I think we're going to stop here today. We'll hook it up to the test box next time and try it out. And we'll make sure we like all the mods. Hey friends, looks like I got a package from a huge fan. It's actually my bud. Same guy with this. Let's see what we got. Might be a surprise. Oh, what's this? It is a neoclone. Whoa. What do you think of that? And check this out. This is a variable treble bleed bypass circuit. That goes on your volume knob so it doesn't get so dark when you turn it down. That's a problem I have with my Strat. So I'm going to try this out. Thanks, brother. I appreciate this. Let's see, do I need to fix this? Do I need to do anything or just try it out? I'm just going to try it out. All right, thanks.